Hi, welcome back. It's Chris. It's been about a week and a half since I made my last video. If you're interested, you can go back and check that out. If not, the quick and dirty is like this. I recently bought a new muzzleloader. I got a CVA Acura LRX in 50 and identified a load that shoots really good in it. I'm using a Powerbelt ELR 270 grain projectile over 3 IMR white hots with a Federal 209A shot shell primer. I'm using a lab radar to collect my velocities and a Kestrel wind meter for environmental data. Now that I've collected all of that information, I'm going to go to JBM Ballistics website and input some variables, and it's going to kick out a ballistic coefficient that matches my hunting environment as opposed to using what they publish on the box, which is developed at sea level at their standard temperature and humidity. Once I have that BC figured out, I can then use another calculator on the same website to generate a drop chart, and that drop chart will tell you where to zero your gun for max point blank range, so you can use the MPBR method if you have iron sights on your gun instead of using come-ups for the scope. So in New Mexico, we can't use scopes anymore on muzzleloaders, so I'm using MPBR with iron sights. I'm going to try it out. So I'm at my bench right now, and I've been mulling over my targets. In my last video, I shot this group right here. It was pretty good. 3-round group measured 0.683 inches. Yeah, 0.683. And the average velocity for those 3 shots was 2,031 feet per second. I also shot these 4 rounds that same day without cleaning the gun. So that group there, I cleaned between each shot. This group here, I did not clean it because I wanted to see what happened. And I thought it was worse than it actually is. I was thinking 3.5, 4 inches, but it's actually 2.907. It's not pretty, but I think it's doable for a hunting gun at reasonable distances. I only collected velocity on 3 of those. My radar was not armed for the first one, but the average velocity for those 3 was 2,052 feet per second. So in that video, I mentioned the week prior I had shot another really good group with that gun, and here's that target. So it measured 0.665 inches, and it's a nice little round pattern 3-round group. The average velocity on it was 2,034 feet per second for the 3 rounds, and the environmental conditions I shot it in were very similar to the conditions I shot the other 2 targets in. So instead of just using the 6 rounds I shot on this day, I've decided to use all 9 rounds from both days of shooting. And what I've done is I've transcribed the velocities for all 9 shots. Here, this is the velocities at the muzzle, and this is where I have my radar programmed to collect a second velocity at 50 yards. So to use that ballistic calculator, or ballistic coefficient calculator, you have to have what they call a near and a far velocity. I'm using 0 and 50 yards for my near and far velocities. So here is the package insert for the Powerbelt ELR bullets, and inside for the 270 grain ELR bullet, it's showing that their ballistic coefficient is 0.263. I'm not sure if that's going to come up or not. It might. Anyway, one of the reasons I'm doing all of this is because I couldn't find that number published on the internet anywhere. They had that information for the 330 grain bullet, but not the 270 from what I could find. So I had to buy a box to see what their BC was. And then I decided to do my own thing and compare it to what they publish. So stand by, I'm going to cut the camera, and I'm going to go get set up on the computer, and I'm going to walk you through the process of generating a ballistic coefficient and a drop chart that shows you your MPBR 0 and your min and max ranges for for MPBR. Stand by. Okay, here I am at the computer. I'm going to go to the JBM Ballistics website now. Find their calculator. So this is their landing page. You go to this ballistic tab. It already took me to where I wanted to go, but if it doesn't, you just hit calculators over here and it brings you to this page. I want to scroll down and go to ballistic coefficients based on velocity, because that's what I have is velocity. So there's already information in all of these inputs, because it seems like this website saves the last information you put in here. And I was tinkering with another gun the other day. So what I'm going to use for my near velocity is 2,039 feet per second. My far velocity is 1,888 feet per second. My chronograph separation is 50 yards, and I've selected a G1 drag function. I'm pretty sure that's what that bullet is. I don't think it makes a G7 form. So my average environmental factors for the two outings was 72 degrees, 2394 inches of mercury. I was at 25% humidity, and the altitude that I do my zeroing and load development at is 6,080 feet. So these two check boxes down at the bottom here, I don't ever use them. I think what this standard atmosphere at altitude is for is maybe if all you knew was your altitude that you're shooting at, and you didn't have temperature and pressure or humidity or any of that, if you just put that altitude in and check that box, it might spit out like a standard pressure and humidity or something for that altitude that you're at. And this pressure is corrected checkbox, since I'm using a Kestrel, it spits out raw station pressure. It's not corrected back to a base. I think you would use pressure as corrected if you were getting your environmental data from a weather app on your phone, like WeatherBug or Weather Underground or something like that. So I'm done putting all my inputs in. I'm going to go ahead and hit calculate. And that's all there is to it. This thing shows you the data that you put in, and here is what it spits out. And this is the bit I'm looking for. So for my conditions, my atmosphere and the bullet that or the speed I'm driving that bullet, my ballistic coefficient is 0.199, where PowerBelt advertises 0.263. It's kind of strange because up here at higher elevation, I should have thinner air, less dense air, being less humid and higher up in altitude, but they're showing a better ballistic coefficient, possibly because they're pushing that bullet a lot harder, maybe. I don't know. Anyway, now what I want to do is I'm going to open calculators in a new tab, and I'm going to do trajectory this time. And once again, there's already information in here from the last time I was using it. So I'm going to put in that new BC that we just generated. I'm going to do 270 grain bullet. It's 1/2 inch in diameter, and my muzzle velocity was 2,039 feet per second. Chronograph distance was 0 yards. I'm going to use 0.950 inches as my sight height, because that's what my iron sights measured. I measured the front sight center to bore and the rear sight center to bore, and averaged those two measurements out and came out with 0.950. So if I was going to continue using the scope and I wanted to use the come-ups on the drop chart, I would put the scope height in there. But since I can't, I'm going to use the iron sight scope height, or sight height rather. There's a spot for wind speed and wind angle, target speed and target angle, and then here you can build your chart. So I want my minimum range to be 0, and I'm going to put 350 for my max range. I'm going to leave 20 as my increment, and I did zero the gun at 100 yards. For my environmentals, I'm going to use the exact same data that I used to generate the BC. Okay, now down here, this is for your MPBR, vital zone radius. So I did a little research, and apparently the vital zone for a mule deer is approximately 10 inches in diameter. So I put 5 inches as my vital zone radius in this calculator, and it's going to kick me out MPBR data for a 10-inch diameter circle. So these two boxes that are checked down here, I think, are checked by default when you come to this website. I don't remember ever changing them. So I'm done putting my inputs in, and now I'm going to calculate it out. And here's the chart that it spits out. So the important bit that I'm looking for currently is right here, maximum PBR 0, 210 yards. Maximum point blank range is 249 yards, and range of maximum height is 113 yards. Basically, if I zero the gun at 210 yards, during that bullet's flight, its highest point will be 113 yards, and its lowest point will be 249 yards. So if I zero at 210, I should be able to hit a 10-inch diameter circle between 113 and 249 yards with a dead center hold. If you're only interested in doing a drop chart for come-ups with a scope, you can change your scope turret range here. I'm using mils because that's what I use, but you could change it to MOA if you wanted to. And then you've also got drop in inches. So this calculator is pretty interesting. You can back up, and it has all of your data still stored. Now I'm going to check this box that says 0 at max point blank range and calculate it again. And it changes the chart with this green bar. So it's basically telling you that with your vital zone radius of 5 inches or 10-inch diameter, from 0 to 240 yards, if you were to hold dead center in the middle of that 10-inch circle, you would strike it somewhere from top to bottom between 0 and 240 yards. That's why I think MPBR is really neat for iron-sighted guns. It takes a lot of the guesswork out. You don't have to hold high or low. You just know with a dead hold how far you can go. If I wanted to hold high, I could possibly hold maybe the top of the deer at about 260 yards and drop a bullet into the vitals. 300, it looks like I'd be holding quite a bit high, 10 or so inches above a deer to actually strike the top of the vital zone. Anyway, that's it for calculating your ballistic coefficient and making a drop chart with max point blank range, 0, and all that other data. I'm going to cut, go back to the bench, and wrap this video up. Okay, I'm done jacking around on the computer. I'm back out here at my workbench. Printed out my drop chart. So my next step is to take the rifle back out and attempt to zero it at 210 yards, because that's what this thing says I need to do to get my max point blank range set up. What I'll probably do is I'll shoot another one of these zeroing type targets at that range, and then I'm going to try and find like a 10-inch sticky target, or maybe I can find something I can print out and put on the box. I may have to draw a circle. I'm not really sure how I'm going to pull it off, but I'm going to get a target that I shoot that is 10 inches in diameter, and I'm going to set it at 113 yards, and then I'm going to set it at 249 yards, and I'm going to try and hold dead center both shots and see if they both land within that 10-inch circle. And if they do, then I will have successfully zeroed my rifle for max point blank range. And what I plan to do after that is bring it back here, and I'm going to clamp it in that vise, and I'm going to sight the scope out the door here and find a distant object, and I'll get the scope pointed at that object, and when I take the scope off and put the sights back on, I should be able to line the sights up to that same object and have a really rough zero on my iron sights. And when I take it out after that, I shouldn't have too much difficulty getting those irons lined up at that same max point blank range. So if you made it this far through this adventure, I commend you, and I appreciate you tuning in. Stay tuned for the next one, where I plan on doing some shooting.